In this video, I'll provide you with a thorough definition of GIS. From mapping to analysis, you'll learn how we use GIS to model the world around us. Let's get started. GIS stands for Geographic Information Systems. It's a computer-based tool that examines spatial relationships, patterns, and trends in geography. Using a GIS allows you to store, analyze, and visualize data for geographic positions on Earth's surface. There are four main functions of a GIS. First, a GIS has a data management component for storing geographic locations. Secondly, a GIS visualizes geographic data typically using maps. Thirdly, GIS software can analyze spatial relationships and patterns using geoprocessing. And finally, a GIS can either create new data or edit existing data. Let's take a look at each of these four functions. At number 1, we're going to look at the role of data management in GIS. Data management in GIS is the process of organizing, storing, retrieving, and maintaining geographic and attribute data. GIS data consists of either vector data or raster grids. First, vectors are points, lines, and polygons with vertices. For instance, administrative boundaries are often represented as polygons, whereas something simple like fire hydrants is stored as points. Roads are a good example of line data. The other type of data type is raster. For example, satellite images, aerial photographs, and digital elevation models are examples of raster data. We also call it grid data, because it's represented as rows and columns. We use these two data models every day in GIS. Each type has its own strengths and weaknesses, and is better suited to different kinds of spatial data and analysis. At number 2, we have visualization. Let's say you have latitude and longitude coordinates in a table. I think you can agree that it's really difficult to know where those locations are. But once you show the data on a map, it provides geographic context so you can fully understand where these locations are in the real world. GIS works with these physical locations instead of tables, and we map it all out. Here are some of the most common types of maps. Choropleth maps use shading or color to represent data values for different regions or polygons, such as visualizing demographic or socioeconomic data. Heat maps use shading to represent the intensity or density of data values in an area. Heat maps are often used for visualizing spatial patterns in data, such as crime or traffic density. An isoline map is a type of map that uses contour lines to represent data. They connect points on a map that have the same value, such as temperature, elevation, or rainfall. At number 3, we're going to look at geospatial analysis. The purpose of GIS is to analyze geographic relationships and patterns using geoprocessing. Geoprocessing can be used to perform a variety of tasks, with a focus on extracting meaningful information from geographic data. For example, a GIS can identify the shortest route between two points, or it could create buffers around features. It can also overlay different data layers to identify spatial relationships, and conduct statistical analysis on geographic data. They say you don't truly know your data until you can visualize and analyze it geographically. Through spatial analysis, you can solve location problems to measure, quantify, and understand our world better. And finally, at number 4, we're going to look at the role of GIS editing. GIS data is a key component in the development of accurate and effective applications, because without geospatial data, the field of GIS wouldn't exist. Editing involves building new datasets from the ground up or updating existing geographic data. It's important because it ensures that the data being used is accurate, up-to-date, and relevant to the problem at hand.